In this video, we are going to talk about dividing polynomials. So there are a couple of different methods that we are going to use. The first one that we're going to talk about is polynomial long division. So in order to understand polynomial long division, it helps if we just kind of recall how integer long division works, right? And so here's an example. Suppose we want to divide 745 by 4. Okay, and then we want to write our answer as a mixed number. Okay, so first thing that we would do is set up our division like so. Okay, and then let me write this down so we can work it out. All right, and so then what we would do is ask ourselves, hey, how many times does 4 go into 7 without going over, right? And we know that it goes in 1 time without going over. So we would put a 1 up here and then multiply, right? 1 times 4 is 4, and then we would write that down here. Okay. And then the next step, right, would be to subtract. So 7 minus 4 is 3. Okay, and then the next thing we would do is bring the 4 down, right? All right, and then we would ask ourselves and just basically repeat that cycle. How many times does 4 go into 34 without going over? That would be 8 times. Okay, and so 8 times 4 would be 32. And then subtract again. 34 minus 32 is 2. Okay. And then we would bring down the next digit, which is a 5. Okay, and then ask ourselves, hey, how many times does 4 go into 25? Right, without going over. So it goes in 6 times, right? And 6 times 4 is 24. And then subtract. And we have a remainder of 1. Okay. So you probably know as well, right? You could add a 0.0 and keep going, but that's not the kind of division that we're going to need to talk about. Here's what we've got, right? We did the division. And so now writing your answer as a mixed number, right, what you would do is, the original problem was 745 divided by 4, right? And we got that was the whole number part, 186. And then for the fraction part of the mixed number, it would be the remainder, which was 1, right, over what you're dividing by, which is the 4. So 745 fourths is 186 and a quarter as a mixed number, okay? Later on in this video, I'll refer to the mixed number format, and this is what I'm talking about. There is one catch though. Remember, we're going to be doing these with algebraic objects, and with algebraic objects you can't write it exactly like this. When you write a mixed number in this way, there is actually a hidden plus in there. So what that really stands for is 186 plus a fourth, right? This mixed number notation right here is really just a short way of writing this number right here. And over time, right, people just stopped writing the plus because, if you're not talking about algebra, you're only talking about mixed numbers, then this is perfectly fine. And it's shorter than this. So people just started writing this in everyday usage, okay? The problem is that in algebra, when you put two expressions next to each other, right, then you can interpret that as multiplication as well, and this is not the same if you interpret that as multiplication, right? So in algebra, that's a big problem. And so in algebra, you cannot write your answer exactly like this. In algebra, that you have to put the plus there, right? Because it's means something else entirely, okay? So that's one little quirk about this. So the reason why I went over this, right, is that this algorithm, the steps in which I take to carry out this division with just regular old integers, is essentially the same set of steps that I am going to use to do polynomial long division, right? You can kind of think of the steps that you go through, or D, M, S, B, R, right? And that's divide, right? When you ask, hey, how many times does 4 go into 7 without going over? That's division, right? And then multiply, right? 1 times 4 is 4. Then the next step would be to subtract. Then the next step is to bring down. So we repeat that part over and over again. And then the last step, right, we get this remainder down here, right? Okay. All right, and so we're going to use exactly the same steps. They're just going to look slightly different because we're dealing with polynomials instead of just regular numbers. Okay. All right. And so I have this example worked out here and here. All right, so next up we are going to apply this to polynomial long division, okay? All right, and so again, the steps are going to be slightly different, and we're going to start off with this example here, okay? So the first step would be to set up your division problem exactly the same way that you do with integers. I write it as x minus 3. Here I have x squared plus 4x plus 1, okay? All right, and let me write this down and we will work through this. Okay, I think that's enough room. Okay, so the first step is the division step, right? And so again, that's going to be slightly off here, right? Slightly different. We're not going to ask, hey, how many times does x go into x squared without going over, right? Or x minus 3 go into this x squared plus 4x without going over, right? What we are going to do, though, is just phrase that in an equivalent way and say, okay, what would I multiply x by to get x squared? Okay. And now a lot of people's reactions, if they haven't seen this before, is, well, what about the minus 3? You didn't like take that into account. And in the division step, you don't need to, okay? In the multiplication and all the other steps, that stuff will get worked out. So in the division step, you're just looking at this first term here and saying, okay, what would I multiply x by to get x squared? Okay, and that would be x. Okay, so I would write an x up on top here. I like to try to keep everything as lined up as much as possible, just because to me it makes that easier. So with this x minus 3, it has 2 terms in here. So I like to put the x 2 terms up here, so over the second term. And if this had 3 terms, well, then I would put it 3 terms deep in here. Okay. So I ask myself, hey, what would I multiply x by to get x squared? Okay, and that would be x. All right, the next step is the multiplication step, right? And so what you would do is multiply this x times this polynomial. And that's really you're really distributing there, right? So x times x will be x squared. X times minus 3 will be minus 3x, like so. So that is the multiplication step. Okay. All right, next up is the subtraction step. And when you subtract two polynomials, right, you change the signs The easiest way to do that is to change the signs of the second one, which will be this one down here, and then do the addition, okay? So this was positive 1x squared. I'm going to change that to a minus 1. This one was minus 3x. I'm going to change that to a positive 3x. And then I am going to add these two terms, okay? So this first term should always drop out if you did the division part correctly, all right? And there's no need to write that, but I do like to write every other term in here. So 1x squared minus 1x squared gives me 0x squared, and normally that first one always drops out, so don't write it. 4x plus 3x gives me 7x. So that is the subtraction step. All right. Next is the bring down step, right? And so when you do that, right, again, I like to try and keep everything lined up as nicely and neatly as possible. So this has two terms, so that would mean that I would make sure that I have two terms in the bring down part of it. So I would bring down that plus 1, and that's also really all I can bring down in this case, right, inside here. But I like to make sure that I have exactly, if this has two terms, then this has two terms when I'm repeating the next cycle. If this has 3 terms, then I like to have 3 terms here, okay? All right, and now I just repeat that. I would ask myself, hey, what would I multiply this by, x in this case, to get 7x? All right, and the answer would be a 7, okay? And so that number goes up here. So that would be plus 7, like so. Okay? So that's the division part over again. Next is the multiplication. I would multiply 7 times each term here. So 7 times x is 7x. 7 times minus 3 is negative 21. All right, so that's the multiplication part. Next is the subtraction part, and so I would change the sign of each of the terms and then add. So 7x minus 7x gives me 0 x's, which I'm not going to bother to write, and normally that first one I'll never write, and then 1 plus 21 would give me 22. All right, so now you see I'm at the end over here. All right, and now it comes time to write our answer, okay? And you're going to see that we're going to do that exactly the same way that we did it when we were doing just regular old integer long division that you learned in elementary school, right? So in this case, that would be x squared plus 4x plus 1 over x minus 3. And you can see that follows the same pattern as in the example that we did. It was 754 or something like that, or 745 divided by 4 in the integer example. So here it's x squared plus 4x plus 1, right? And then over the thing that you're dividing by, right, is x minus 3. All right, so that's the original problem. And then an equals, okay? And then how do we write our mixed number format? We took the integer part, right? And in this case, you just take that same part, right, the x plus 7, and put it there, and then put a plus, and then whatever the remainder is, in this case it's a 22, right, put it over what you're dividing by, x minus 3. Okay, and that plus right there is that hidden plus that we talked about that's in mixed numbers, okay? With algebra, you must write that, okay? If I write and don't put that plus there in algebra, that means a totally different thing than it does when the plus is there. So there's no getting out of that. You have to write the plus in algebra, okay? All right, so that is it on this problem. All right, and here we go. All right, next example is divide x cubed plus 2x squared minus 3x minus 1 divided by x minus 2. Okay, so let me reset my whiteboard and then write this problem down. So x minus 2 and x cubed plus 2x squared minus 3x minus 1. Okay. So again, we just kind of repeat this cycle. We would ask ourselves, hey, what would we multiply x by to get x cubed? And that would be x squared, right? So I would put x squared up here, 2 terms deep, because this has 2 terms. And then multiply. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. All right, next is subtract. So I change all the signs and add. So when I do that, I have 1x cubed minus 1x cubed, and they drop out as they always should. And then 2x squared plus 2x squared gives me 4x squared. Next, I bring down, and this has 2 terms, so I want to make sure that I have 2 terms here. Okay. All right, and now I'm ready to start the cycle again. All right, so I would ask myself, hey, what would I multiply x by to get 4x squared? And that would be plus 4x. All right, next is multiply. 4x times x is 4x squared. 4x times minus 2 is minus 8x. All right, and so next up is subtract. So change all of the signs and add. All right, so here these drop out as they should. Negative 3x plus 8x is positive 5x. And then bring the next term down, minus 1. Okay, then next up, hey, what would I multiply x by to get 5x? That is a 5. Okay, and then go ahead and multiply. 5x, 5 times x is 5x. 5 times negative 2 is negative 10. Subtract, so I change all the signs and add, and I get a remainder of 9 there. Okay. All right, next up I want to write my answer in the mixed number notation. Oops, that's the wrong thing. Got the wrong part of the screen. Well, I mean, that's actually okay. I just want to write the complete answer here because it's important later. All right, so that's the original problem. And then what is that equal to? That's equal to this part up here, x squared plus 4x plus 5. And then the hidden plus, then the remainder, which is 9, over what you're dividing by, which is x minus 2. Okay. All right, so that's it for that one. Here we can see the results of that and the answer. Okay, so there are a couple of important things I need to tell you about, and that is I didn't want to do this for the first couple of examples, but before dividing polynomials, there's two important things that you need to do. Number one is write the polynomials in descending powers of x, and two, fill in for any missing powers of x. Okay, so you've got to do that before you divide. We didn't have to do that in the first two examples because they were already like that, but in general, you do have to do that. And so, the reason why that you have to do this is because with regular numbers, right? Remember this, these steps that we're using are the same as the ones for regular numbers. Well, if I have a number that looks like this, right, 321, the order in which the digits are matters in our system, right? In other words, if I have 1, 2, 3, well, that's a totally different number from 3, 2, 1. But in algebra, right, I could have, something like this, x squared plus 2x plus 3, right, and 3 plus 2x plus x squared. Those are two polynomials. Oops, sorry. These two are considered the same, right? Even though it's 1, 2, 3 and 3, 2, 1, because the x and x squared kind of hold the place for us. We don't have that in regular numbers, so these numbers would be totally different. But remember, we are using the steps, right, that of the regular integer division. So what that means is we've got to write these in the normal order. If you have this polynomial, it has to be written like this, since we're using essentially the same algorithm, right, or same set of steps for regular integer long division. You have to rewrite it like that. The second thing is to fill in for any missing powers of x. Let's say with numbers, right, if I had 45 and 405, those are two totally different numbers in our system, right? But in algebra, right, if I had 4x squared plus 5 and 4x squared plus 0x plus 5, those are the same polynomial, right? This one's just written in a more simpler form than this one, right? So whether you write that 0 there or not for polynomials doesn't really matter. It really matters, right, for integer division. And so again, since we are using the steps for regular integer division, we've got to go ahead and fill in for any missing powers of x in there, okay? So you got to always check that first. All right, so let's do an example like that. Okay, so here it says divide x to the fourth plus 3x squared minus 4x plus 1 by x squared minus 1 using polynomial long division. So we can see, right, that we are missing some powers of x here. This one is missing the x cubed. So we would need to write it like this. Okay, so it now has descending powers of x. That checks out okay, and we filled in for any missing powers of x. Likewise, this one is missing a power of x, right? So I would need to write this one as plus 0x minus 1, like so. Okay, and so it will look like this when I get it set up. Okay. All right, so let me write that one down. And then we will run through this one. Okay. All right, right, so the first thing I would do is the division step, right? And again, I'm just looking at this first term over here, and I would ask myself, hey, how many times does x squared, right, go into x to the fourth? And or what would I multiply x squared by to get x to the fourth? And that would be x squared. So I would write x squared on top. And again, because this has three terms, I would write it three terms deep here. You don't absolutely have to keep things straightened out exactly like I do, but I just like that better. To me, it's easier to keep track of all the stuff if you keep everything lined up nice and neat. So next is the multiply phase. X squared times x squared is x to the fourth. All right. And then here I have x squared times 0x. And now this also seems a little weird in that you would normally not write that, right? X squared times 0x is 0x cubed, which is just 0, and normally you don't write that. But in long division, to me, it helps to keep those zeros there, again, to kind of keep everything lined up nice and neatly there, okay? All right, so next up, I would multiply x squared times minus 1 here. So I get minus x squared. Okay. All right, next up is subtract. So I am going to subtract, and so that means change the sign of every term. Right here, you can put minus 0 if you want, but it doesn't really matter because it's still 0 anyway. And then I'm going to add. Okay, so this just drops out, right? And you get nothing here. And again, here I am going to go ahead and put this 0 in here and keep it in here just to keep everything lined up. And now you'll see some people will not do that. I just like to keep everything in there because I think to me, it just makes it easier, even if you're going to add extra steps in here. So this first one I'm not going to write because it's 0, but you're going to see this one I am going to keep in there. So I have 0x cubed plus minus 0x cubed. Well, that's just 0x cubed, right? So I am just going to keep that in there and keep it as it is, okay? All right, and then I get 3x squared plus x squared. That gives me 4x squared, like that, okay? So next what I would do is bring down, right, the next term, which is minus 4x. Like so. All right, and then ask myself, hey, what would I multiply x squared by to get 0x cubed, right? And so that would be 0x. Right, just double check that that works, right? I would have x times x, which is x cubed, right? And then 0 times this understood 1 out here gives me the 0. And now if you've done this before or seen it before, you might say, well, can I just skip that step because of the fact that that's just 0, it doesn't go in. And you absolutely can do that, right? But again, I feel like when I'm explaining this to people who may have not seen this before, I just kind of feel like it's easier to keep that 0 in there at first. And that way everything stays nice and lined up in there. All right, and you're going to see what happens this step. When I do this, I just get 0 x times 0x squared is going to be 0x cubed. And I get 0x squared. And I get 0, right? Because 0 times minus 1 is 0. X, like that. Right? And so that's why some people will just kind of skip this step, right? Because of the fact that that's all zeros right there. Again, I'm trying to keep everything lined up because I think it's easier that way, right? All right, next is subtract. So change the sign of everything, even though it doesn't really matter. Okay. And keeping with what we've been doing exactly when all these are not zeros, right? I would not do this one. These are gonna always not, the very first terms are not gonna work, right? Or they're gonna cancel each other out essentially. So I'm going to not write those, but all the other terms I'm going to write, right? So here I have 4x squared plus minus 0x squared. That just gives me 4x squared because I'm adding. And then minus 4x plus 0x gives me minus 4x. All right, so next I'm bringing down that 1. All right, I'm going to bring that down and then ask myself, hey, what would I multiply x squared by to get 4x squared? And that's going to be a 4. So I'm going to write the 4 up here. And then I am going to distribute. 4 times x squared is 4x squared. 4 times 0x is 0x. 4 times minus 1 is minus 4. Next, I'm going to subtract. So change all the signs and add. So when I do that, I get these drop out like they always do, and then minus 4x plus 5. Okay, so there are the steps of the division. Okay, and I'm going to go back here and write that out. So again, if you are used to doing this and you're used to just like skipping from here to here, or skipping over this part, you go ahead and do that. I'm not going to take off points at all for you doing that. That's how I kind of learned it. But to me, there were some parts of that I found confusing until I got used to doing it over and over again. And then I didn't really have any problems with it. But to me, in retrospect, I kind of wish it had been filled in with these zeros like this because to me that would have made a lot more sense. So anyway, just skip these if you don't want those in there. You're free to do that. All right, so let's go back here and write our answer. All right, so this is what we had. Okay. And so to write our answer, right, what we're going to do is go to the original problem. And when we write our answer, we don't need to put those zeros in there anymore. So you can see I've just taken the zeros out because we don't need them. So we have x to the 4th plus 3x squared minus 4x plus 1 over x squared minus 1 right here. And what is that equal to? That's equal to x squared plus 4. And then plus the remainder, right, is this one right here over what we're dividing by right here. All right. So you can see when there's missing powers of x in there, it does add those zeros in there and make it a little bit more complicated. But I feel like leaving the zeros in there just really helps. Okay. Last example on this one. We are going to divide 1 minus x cubed by x squared plus 4. So 1 minus x cubed, number one, we have to write that in descending powers of x, right? So that would be minus x cubed plus 1. And then we also have to fill in for any missing powers of x, and there's some missing, right? Minus x cubed, the x squared is missing. The x is missing. Okay, so we have to write those in there. And then the x squared plus 4, it is written in descending powers of x, but we are missing that x term, so we have to fill in for it. So that would be x squared plus 0x plus 4. Like so. All right, and so that is going to look like this when we get it set up. All right, and write this down. All right, let's see how that looks. Ooh, that's way too low. All right, I'm gonna have to redo that. Sorry. All right, just hold on with me while I redo that. All right, let's try this. All right, looks okay. All right, so the first thing I'm going to do is ask myself, hey, what would I multiply x squared by to get minus 1x cubed? And so that would be minus 1x. I'm going to put that 3 deep, right? Because this has 3 terms. And then I'm going to multiply. Minus x times minus x squared is minus x cubed. Minus x times 0x is 0x squared. Minus x times 4 is minus 4x. All right, then I'm going to subtract, so I'm going to change the sign of each term and actually add. Okay. So the first terms are going to drop out as always. Here I have 0x squared plus minus 0x squared. Again, I am going to add that extra step in there and just keep that 0x squared. All right, 0x plus 4x is going to give me plus 4x. Okay. All right, next up is the bring down phase. I'm going to bring down this 1. All right, and now I'm ready to go back to division. So I'd ask myself, hey, what would I multiply x squared by to get 0x squared? And that would be a 0, right? So I'd write plus 0 on top here. All right, and then 0 times x squared is 0x squared. 0 times 0x is plus 0x. And 0 times 4 is 0. All right, so again, that's one of those weird steps you actually can skip. But to me, it's actually more strange if you skip it, because then just sometimes you're just kind of left hanging like, what just happened there if you don't put those steps in. Again, totally optional as to whether you do that or not. So change all the signs, even though you're really not changing anything there. And then 4x plus minus 0x is just going to be 4x, because that's really just 0. And then 1 plus minus 0 is just 1 plus 0, which is 1. And there we now know that we are at the end. Okay. All right. And now we're ready to write our answer here. All right, the original one was 1 minus x cubed. Right, this here, now that we're writing our answer, we don't have to fill in with the zeros anymore. And the bottom was x squared plus 4. And that is equal to minus x. In the answer, there's no need to write this plus 0. And then it's going to be the remainder, 4x plus 1, over what I'm dividing by, x squared plus 4. Okay, and that's it. And I think that's the last example for polynomial long division. Okay, and so in the next video we will talk about synthetic division and the difference between it and polynomial long division, and then how to do it.